Okay. Okay, you guys. Yesterday, shh, Zach, TJ, Cole, you better sit over there. Okay. Yesterday we did the area of a sector, current, and all you do for the area of a sector, just to review that, is it's part of a circle. It's not the whole pie or the whole cake. It's not the whole thing. It's pi r squared, and it's a fractional part. Okay, Zach? So I take this, call that measurement A. In this case, it looks like it's a quarter of a circle. And I take A, Karen, out of 360. That gives me the part of the circle that I want. You're not going to eat the whole pie. You have friends over for Thanksgiving dinner. You only get a slice of pie. You don't get the whole thing. Some of you maybe took the whole thing, but there's the slice of the pie. So this is the fractional part. Not everything. It's not one. It might be close to one. Okay. Tomorrow, TJ, we're going to do the segment of a circle, which is the hardest one of them to do. But today we're going to do the annulus, and I want the area of just the shaded part. I prefer to call it a washer because it looks like a washer. It looks like a DVD or a CD. TJ, do you have to leave? Either participate or you leave.
All right, I don't give a
Okay. Shh, Cole.
Well, you don't have your iPad out.
Shh, Curran. Not our problem. Now, you guys all have DVDs and CDs. And in the old days, these actually were records. And I just want this shaded region that's in between these two circles. So how would you find that area?
You find the area of the circles and then subtract the circles.
Yeah, find the area of the two circles. Let's use capital R for the big circle. So the area of the annulus is the area of the big circle, which is pi capital R squared minus pi little r squared. And in calculus, we call it a washer. You guys have all seen washers. Yes, when if you build something, a little washer, the disc. We do a lot of this. This is for the radius of the small circle. And this is the radius of the large circle. And that's all there is. Is that the same as this? Pi r minus little r squared. No, it's not. Guess what they do in calculus? Many students do. We use this, but they want to go to this. It's usually easier to deal with. But if I wanted to do this, this would be pi, it would be capital R squared minus 2 capital R little r plus little r squared. Guys, if you're talking, you can't be listening. Emmanuel?
Is this AV1 lesson 2?
This is lesson 3. You already have it in Notability. You should. These are not the same. So find the area of the big circle, find the area of the little circle, and subtract. And that's all there is. So we're going to go, we'll put the notes in here on the next page. An annulus. Whoops. Not that page. I got to go to the right page. So we're going to slide down. Those are segments. We'll do that tomorrow. They're harder. And hopefully tomorrow we'll have a better start. So it's page 10. So an annulus, or a washer, is the region trapped between the large circle and the small one. Depending on the pie, it's kind of like the crust of the pie. It's not very wide on a pie, right? Mine's usually pretty good. Okay, so Cole, what's the formula again?
The big area of the circle minus the small area of the circle.
That's it. And some of you are resistant to writing down the formulas. If you're going to try to find a radius, you're going to have to write down the formulas. Okay, are you ready to try a few problems?
Yeah.
Very straightforward problem. Sydney, put your phone away, please. I'm going to do what Mrs. Hersman does. I'm going to get a technology bag, so when you guys have your phones out, I'm just going to put them in my technology bag, and I'm going to hold them up here while I teach. During work time. This isn't work time. That's the problem. Okay, so we're going to write the formula down.
I was gonna get batteries, but or I was looking for batteries in my house. We were gonna go get some actually.
Okay, it's pi big radius squared minus pi little radius squared. What's the big radius? TJ?
6.
9.
9 minus pi times the little radius.
3.
Okay, so go ahead and do that. Tell me what the answer is. I know what the answer is.
9 plus.
So you should know, you got to square it, 81. Where's your notes? It'll work. Pi's don't cancel out. They don't. Oh, I'm not even going to use a calculator. Where's your notes? This is 81 pi minus 9 pi, or 72 pi. Now, I know it's about 140 or so, because that's 3.
No, it's two,
Two,
200.
3 times, 210. I can do the arithmetic. Cool.
You have to like solve it.
Do you have to, not solving, this is not an equation. Do you need to simplify that or evaluate it more? No, you can leave it in terms of pi. Yeah, that's a lot easier. Okay?
What you can do, you can cancel out the pies.
You can't cancel the pi's, you're subtracting them. That's like saying 81x minus 9x. You can't cancel the x's. If you divide 81 pi divided by 9 pi, then you can cancel the pi's, because you're dividing numerator and denominator by pi. We'll review fraction work as we go through this today. Okay, Sydney, your iPad should be going. If that doesn't work, give you a piece of paper. Now, let's try the next one's quite a bit harder. I want the area of the shaded region. Well, let's just brainstorm this a little bit. Worse than that, I want to find out what x is. I don't know what the radius. I don't know what the angle is. Okay, so here's what I would do. First, let's label what we know. I know the radius of a large circle is 20. So this is 20. And the little circle is 16. So that's 16. And if I don't know what to do with that piece, it's like a sector. It's just the crust from one side over to the other. Why don't we do the whole thing? I can find the area of that ring, right?
Yeah.
I can. I don't want all of it, but let's first find that, because I can do that. So it's pi big radius squared minus pi little radius squared. So the area of the whole annulus, I'll just call it A, equals that. So it's pi. What's the big radius? 20 minus pi. What's the little radius? 16. Do you guys know what those are squared? 20 times 20. You guys can do 20 times 20.
400.
That's 400 pi. Did anybody know what 16 squared is besides me? What is it? 256. And you're going to subtract them. So it's 400 pi minus 256 pi. What did that subtract to give us? 144 pi, right?
Yeah.
Don't forget the pi. Okay, Zach? Don't forget the pi.
I won't forget the pie.
Okay, but you know what? I don't want that. I want only part of this. I don't know. What part, you can't just guess. Okay, TJ, what part of this annulus do we have? What fractional part? You have x out of how many? 360. I have only part of the annulus, not the whole thing. I have this fractional part, I don't know what x is, times the area of the whole thing, which is 144 pi. What's that equal to, Cole? No, I don't. It says the area, the shaded area is what? 20 what? 20 pi. Now, if we can get that, that's the geometry. The rest is algebra. Okay, I could reduce the 144 and the 360. Some of you don't want to do that. Just fine. You can use a calculator. What's going to happen to the pi's?
Cancel out.
They cancel out, so I'm going to divide both sides by pi. So it's 20 equals 144 over 360 times x. Question?
So yeah.
You guys, go. You're supposed to be participating. You're not participating. I just switched the 144 and the x. I can do that. Commutative property says if I have 2 times 3 or 3 times 2, it's the same thing. I just did it because it makes you happier to see it like that. Okay, so now you want me to get my calculator out. I know that 12 goes into 144 and 360. In fact, more than that goes in that. And I could reduce, but we won't do that because you guys are going to use calculators. And so I'm going to get my calculator out, and I'll show you what my calculator can do. And if you have an 84, you also can do that. Let's try it this way. Oh, that's much easier. Because I can see it better. There's other colors. Okay, so I'm going to clear that out. I want to see what fraction that is. What number do I have here? 144 over 360. So if you have an 84 calculator, you can get from me or from somebody who has the new operating system, you go alpha y equals, and I have these extra buttons here. Those are fraction buttons. That's the numerator and the denominator. So I'm going to press that, and now I can put in 144, and I can put in 360. It'll reduce it for me. So if you're not good with fractions, I highly recommend this. The answer is 2/5.
So it's 2/5 x.
Yeah, equals 20. Now, do you want to do that, or do you want me to change it to a decimal?
Change 2/5.
So you guys are probably going to do 144
It's not.
divided by 360. I'll get a decimal this time now. 0.4. Well, yeah, but I'm just saying you're going to start with that. So I get 20 equals 0.4 times x. Now we know how to solve this. At least I hope we do. Do what?
No.
Divide by 0.4. I suppose you need a calculator, but how many times does 4 go into 20? 5. I had to bring the decimal over. It's 50. Remember how to do decimals? You add a decimal here, and you bring this over 1, and you bring this one over 1, and so this is 5 and a 0. It's probably been a while since you divided by hand. However, on the AP exam, 40% is without a calculator, and in most colleges, you're not allowed a calculator of any sort. So you have to know some arithmetic. So yes, they would expect you to know how to do that in college. No. Depends on where you go to school. Notre Dame, no calculators at all. And it depends, at Minnesota, it depends on your professor. Okay, so that was a hard problem because I had,
X was.
it's 50 degrees, because I had to find the fractional part of that.
That looks a lot more than 50 degrees.
Remember, we can't draw it to scale necessarily.
Should though.
Well, whoever made the problem probably didn't know how big it was when they set the problem.
That looks like 100.
But you can't ever assume from a picture. Are you ready to try another one?
Yeah.
And we had a problem kind of like this on the assignment you may be asking me a question about. Maybe I'll answer it right now. I want the area of the shaded region. There are really a couple ways to do it. I can find the whole annulus, and then I can subtract off the part that was taken away. Or I could find just the fractional part of this annulus right here. So if that's 30 degrees, if this is 30 degrees, how big is that? What fractional part do I have?
30.
Okay, so that's 330 degrees out of 360 degrees, which is pretty close to the whole thing, isn't it? So the only difference here when I'm doing parts of these is I have this fractional part, but the formula for the annulus is still the same. Pi r squared minus pi little r squared. It's always the same.
It's 6, the big one's 6, the little one's 4.
Okay, let's reduce 33, and now, I'm sorry, I did that quickly, but if I divide by 10 and 10, the zeros go. If you haven't seen that, it's really a nice thing to know how to do. What goes into 33 and 36?
3.
Okay, so we're going to divide by 3, and we're going to divide by 3, and I'm going to get what here? 11, and this will give me 12. Great.
11, 12.
So you can see it's pretty close to the whole circle. I can see it better with 11 12 than I can see with 330 out of 360. And then Cole said the big radius was what? 6.
And then a little one.
Now, if you read through this, is it clear what I did? Those of you who just kind of push numbers around, I can't sometimes figure out what you did. So it's nice if you showed your work. There's the plan. So it's 11 12. I'm not going to get my calculator out. I'm too lazy. 36 pi minus 16 pi gives you what? 11 12ths of what? 20 pi. And yeah, we could reduce it. It's fine. We got the answer. Okay with that?
Wait,
And if you want to put,
right?
yeah, I mean, it's pretty close to 20 pi. 11 out of 12. Maybe it's 18 point something. I don't know. I just know it's pretty close to 20. And that's what you do with the annuluses. And so if you go to the next slide here, there are all the formulas. The one we haven't done is the segment of the circle. That's the hardest one. And that's all there is. So let's do some questions off of the homework. I want to bring that slide up because I have a feeling you have some questions on lesson 3. I could be wrong. You were supposed to do the green packet. I'll try to make this so it's not yellow. You're gonna the assignment's on the board, and I should have written it down on the slide there. Yes. I'll put it in Schoology in the updates. I did yesterday, at least I think I did. This is what we're going to do today. I think I got the right one. We want the one with the circles. Like, this is number 10. So let's go through here, and I'm going to circle them. You want 6 through 8. You should have done, this is what should be done. 1, 2, 3, because we can do that. We don't know how to do 4 or 5. 9, 11, and you're going to ask me questions on these. And 13. Okay, now what can you do tonight or today, which you probably should get done? Not 4 or 5, because I haven't done that yet, but 6, 7, 8. 8 looks hard, but 8 looks just like what I just did, except not a 30-degree angle, it's a 60-degree angle. And you can do 10. So I forgot I was going to change colors, but that's okay. And 12 and 14. And then behind me, the worksheet 1, 3, 5, and 10. And if you don't get it all done, you know what? Tomorrow's is probably not going to take us that long. So now, of 1 through 3, which ones are you okay with all of those or not? Are there any ones you want me to do? 13 was should be done for today. So you may have a question on that.
No, we're doing that yet.
Okay, so we haven't done 4 or 5,
Exactly.
and that's it. There aren't that many problems for those, but I've got some other stuff coming. I will put on Schoology some challenge problems for those of you who like to have a little more challenge. I'm hoping there's at least one of you in here. If nothing else, go check out my artwork. They're really nice. I don't know. Do we want to do 3?
No.
Well, you can look at the answers.
It's 192.
No, because they're not.
Yeah, they are.
No, isn't it just 90? So A equals
No, I want the shaded region. So what part of the circle for 3 do I have? Well, there's 2 ways to do it. I would take 3/4 of the circle, because that's what I'm going to have. Or I could take 1 whole circle minus the part that was eaten, 1/4 of the circle. Still get 3/4. It's the same thing. So the answers are online, so you can check them.
This is a lot, like, the first one is pretty easy.
1 through 3 should be okay.
No, number 6.
Yes, that one should be easy too.
That one's pancake.
Sydney. Oh yeah, we have the diameter for the big circle is 10, so the radius is 5. So I have all my work. I haven't put my work up yet. The little radius is 2. This is capital R. Okay. What about number 9? Do you have number 9 done?
How do you do number 7?
We should work on yesterday's first.
No, but I'm already.
7 is for today, for tomorrow. For tomorrow. Mm-mm.
You have me circle it though.
Yeah, that's what you could. No, we're not on that sheet. We're on the green. But that one you should be able to do too. How about number 9 on the green? Yeah. You just did that one. I just showed you. The diameter is 10, so the radius of the big circle is 5.
Oh, that's nice.
Yeah. The green one, number 9. Show your work. I don't see your work here. Yeah, don't copy the stuff off the web. You know what? Copying off the web doesn't do you any good. Doesn't do you any good. So you get points. Big deal. They don't even count in your grade. Only it counts in your grade, really, is your summative. If your formative brings you down, then I look at your summative, and I look at that and use that.
I think I forgot to.
What's the formula for this?
Area of the big circle minus area of the little circle. Pi r squared. Okay, Sydney. Still looking for number 9.
Your indication on me is not
Would I divide those by 3?
Yeah, you can probably bigger than that, but yeah. First off, get the zeros out. The end zeros go. So then divide by 3.
Divide those by 3?
Yep.
Like, do we have started off with, like, the fraction?
No. You can find the whole area and then find the fractional amount. How about number 9? Still not sure if we got number 9.
Pretty sure you're wrong.
Those of you who did it, were you okay with number 9? Do I need to do number 9 off the green one? Backside. That was a little tricky. And what was even trickier was the next one. How about 11? I did them in the other class, but they are all worked out on the web. No, I don't think it is. Well, let's look at, I don't know what the answer is. The answers are online. Okay. The area of the shaded region.
Hey, Miss G, number 9 is R just referring to that previous one.
Yep. Is equal to A out of 360 times the area of the circle. Okay, you guys? The area of the shaded region is 12 pi equals 120 out of 360, which I hope you can see what that is, pi r squared. No, the answer is 6. The answer to this is 6. Okay, first question is the setup. Okay, do you understand that?
Yep.
What happens to the pi's?
They cancel.
They cancel out. Can I reduce the 12
Yeah.
over 36?
1/3.
So 12 equals 1/3 of r squared. Now, I don't want the 1/3 there, Curran.
Yeah.
1/3 of 12 is 4.
No, I don't have 1/3 of 12, though. Oh, that's the problem. I have 1/3 of the square of the radius. So I'm going to multiply this side by 3 and this side by 3. Yes. It's now 1/3 of 12. So 36 is equal to r squared, so r equals, yes. What's the problem?
On 8, I almost
We can go back and look at 8. Okay, what's the fractional part? So then it's going to be 144 pi minus 81 pi. 63 pi? That's fine. You can use a calculator, or I can still go further.
Did we get 300 over 360?
Yes,
Oh, yeah.
because I want the outside. So what we'll do is divide this by 2, which gives me 5, and divide this by 2, I get 6. So I have 5, 6 times 63 pi. What goes into 63 and 6? 3. So if I divide by 3, I get 2. I get 21. So I get, Zach, 105 halves pi. And unless you go to decimals, that's nothing more you can do. So get your calculator out and multiply it out if you want. What?
Why do you do 5? Oh, 5.
It's 49 pi minus 16 pi. This is just fraction work. We're having more problems with that than the geometry. Yeah, that's fine. Yeah. You won't be able to check your answer. You'll have to divide it to check it. How about 11? Did you guys get 11? Was 11 okay? Marie, was 11 okay? That was a tough one numerically. Zach, did you get 11?
I am in progress.
Let's do that. Oh. Okay, area of the shaded region is equal to A over 360 pi r squared. Okay, Zach, what's the shaded region? Do I know it?
The shaded region is 120 pi.
No, this is going to go down on the board because there's a lot to do here.
120 pi
X over 360, and it's pi times 24 squared. Does anybody know what 24 squared is besides me? Karen, do you know what 24 squared is?
24 squared. Easy peasy lemon squeezy. 576.
You had a calculator to use her. No.
Okay. Sydney. Okay, let's finish this one, then we'll go back to 10, okay? Okay, current. What's getting up to pi?
What?
Let's get up to the pi. They're going to go away. Okay, numerically, this is where the problem is. It's 576. Guys, there you guys. Now, you can divide it. I've already done the problem, so I know it's 1.6. Once I make that 1.6 Cole, is that easier to solve for x? Because what do? Divide by TJ. And that's it. Okay, number 10. I want the shaded region, which is the whole annulus, it's the whole washer. So it's the area of the annulus equals pi capital R squared minus pi little r squared. And I want little r. What's capital R? Sydney? What's capital R? Okay, so the shaded region's 32 pi equals, let's see, I've got the big radius, which is 9 squared times pi minus pi little r squared. Yes, I did. What's this going to give me? 81 pi. Okay, what do you do next? Zach, what do you do next? I could, if as long as I take a pi from every single one, it's okay. So I get 32 equals 81 minus r squared. It's going to work. Then what do you do next? Subtract what? 81. That gives me a negative number. No, it's not wrong. It's negative what?
49.
49 equals negative r squared. So what's positive r squared? Zach, do I have to put you someplace totally different?
No.
R equals 7.
See, Gary would be lost.
Yeah, you guys can't sit together.
What now?
I would be lost.
Yeah, he would.
No, unless Gary wants to help me again.
Okay,
Last time I didn't sit by Gary, it was just chaos. Like, this whole-
did I answer all your questions so far?
Can you go back to number 8?
Yes. Now, these are all, I haven't gotten them up on the web yet, but I have mine all worked out. So it looks just like this.
So, what?
What's your question?
Wait,
It's
you just
300 over 360 because we have to take the big outer angle.
You just divide that. So you divide 300
It's 5/6.
by 6.
Yeah, 360.
360 divided by 6, or 300 divided by 6.
Well, first off, we did the tens
Yeah.
to make this easier. Boom.
So it's 36.
So it's 30 over 36.
Okay.
And then we divided by 3. So it's 10 over 12, and then I divided by 2. Because didn't think about 6. That's okay. Just doing parts. Okay, so you guys, the assignment, I'll have it on the video as well. It's basically to finish the green sheet except for skip 4 and 5 on lesson 3 worksheet. And then on the white worksheet, we are doing 1, 3, 5, and 10.
So, so you divide 0.8 by, or you times 0.8 times,
Where are you getting 0.8?
because 5, 6.
It's not 0.8. It's a repeating decimal.
Oh, it is?
Yes?
Well, then what do you, alright.
Got to repeat. Now, I don't know if you know that. Those of you who have iPhones, some people are saying they don't have pi on their phone, but yes, you do.
You have to turn it.
You have to turn it to landscape mode. Just turn it, and you get all the other fancy things, the trig and stuff. Personally, I don't like that one, but that's okay.
So you divide 3 by 3, what?
Just take 5, 6 times 63 times 5.
I don't understand. Well,
5, 6.
It's a decimal. It's a repeating decimal. So multiply across the top and divide by 6. 12.
Times
12 is similar to what we've already done.
2.5.
This is x out of 360.
Oh,
And I want, that's the part of the ring. So it's pi capital R squared minus pi little r squared. And that is going to equal 10 pi, because that's the shaded region.
alright, so you do
So you got to put numbers in. Yes.
pi